Let's move on to the third example of example number 1. Y is equal to 5. So let's just sink that in. Y is equal to 5. If x is equal to y is equal to 5, guess what your y value is for any x value? That's right, it's 5. So if x is equal to -3, y is 5. There we have it. So the y value stays constant. What does this look like on a graph? So I'll just graph those points. So if x is equal to -3, -2, -1, 0, what we get is a horizontal line. So it's a horizontal line because the y values remain constant at 5. Now, this is a horizontal line. I always spot out a horizontal line because it looks the opposite of what you think. It's going to have y is equal to. You're going to have that form y is equal to some constant here, like some number. In this instance is 5. All right. Let's talk about this one. X is equal to 3. Guess what? X is always going to be equal to 3. What is your y value? I don't know. It can be really anything. The important thing to take away from this is x is always going to be 3. So let me just throw out some y values. If y is equal to -10, x is going to be equal to 3. If y is equal to -3, x is going to be equal to 3. Now, I understand that I'm going backwards, but it definitely helps out here. X is 3 when y is 0. It doesn't matter what your y values are. X is always going to be 3. So I'm just going to plot out this first point. X is 3, y is -3. If x is 3, y is 0. If x is 3, y is 3. If x is 3, y is 4. If x is 3, y is 5. So we get a vertical line. And guess what this vertical line describes? This vertical line describes x is equal to 3. X is always 3, no matter what the y is. So let me just make sure which equations, let me look over this part here. Which equations represent linear functions? So I am going to say this is a linear function. It is a line, and it passes the vertical line test. This is not a linear function. It is not a line, but it is a function, but it's not a linear function. For C, what we notice, it is a line, it has a line shape, and it passes the vertical line test. So this must be a linear function. All right, D. Is D a linear function? Well, it is a line, but it's not a function because it fails the VLT, it fails the vertical line test. So this is not a linear function. And what we can see is, remember our old definition that a element of the first set maps into only one element of the second set, and what we see is an element of the first set for x maps into a whole bunch of different elements in the second set. All right, example 2. Which table of values represents a linear function? The relation between temperature in degrees Celsius and the temperature. So there are several ways that we can proceed. We can use a graph. That's going to take some time. We can try to create an equation and check if the degree is 1. Yeah, that would work, but that's going to take some time. What is another way Well, we see a table of values. And what I can do is I'm just going to count up the change each time something in our table. And what we notice is that my first variable, C, increases by 5 each time. Now, what would make this a function? A linear function. That is, if I increase by a constant amount. Here, I'm going to increase, yikes, that was scary math. 32, the difference between 32 and 40 is 9. And what I see here is I'm increasing by 9 each time. So as long as the rate of change, you may want to write this down, as long as the rate of change is constant in both elements, in both variables, you have a linear function. You've learned this last year. Therefore, we have a linear function. Why? Because both variables change by a constant amount. All right, so that is example 2A. Now I'm going to go to example 2B. I'm just going to erase this because it's clogging up the way. Now I'm just going to do some math, and what I notice, the relationship between the current I amps and power P in watts in an electrical circuit. And so I is the current, and what I notice is in our table, our current increases by a constant amount, and it's 5. So this is looking really positive. What I notice is that my other variable goes from 0 to 75, so that increased by 75. Can't really tell too much yet. And then the next step up, that increases by 225. This is not a linear function. We should expect the same level of increase going from step to step. So not a linear function. All right.